call is now transcribed. This call is now being recorded.
Okay, welcome everyone to today's topic of our weekly webinar, Data Analytics, Journey to Excellence. In this webinar, what I'm trying to do is look at different types of data analytics and then how they fit into telling story from your data. Really, that's what you're trying to do from your analytics, right? You're trying to get either some kind of story or trying to make some kind of a decision. And what we're going to try to look at is what each type of analytic gets us to in making that effective decision making or building the storyboard that we're trying to do. At the end, what I'll also try to do is cover very quickly through each type as to what we should and should not try to do, or what kind of decision we should or not make out of each data analytics. So let's to do that, let's start with the different types. So there are really 4 different types of analytics that I will cover. That I'll get into very briefly because of the time we have is the approaches for each of the types, the tools and the software which exist out there, or the ones that at least we've used. And then the 4 stages of the journey for those 4 types, journey to excellence, how you move forward. And finally, as I said, some of the questions to ask of each type. So what are the 4 types? The very first one that everybody is aware with is the dashboarding reporting kind of analytics. Really, what you're doing here is looking at the data patterns to gain insight into the past, right? So you're looking at historical data. Did I achieve what I was supposed to achieve? How did I do yesterday? What were my costs? Like some of the metrics might be cost, throughput, satisfaction rate, throughput rate, some kind of a ratio, some kind of a pass-fail. But really what you're trying to do is look at the performance of the past, right? And then trying to understand if the critical set of historical performance met your needs, right? Some basic data or statistical analysis is also used, so just to see maybe means on average how we're doing, average of different days, average of different shifts, average of different crews, machines. So there's some stats in it, but largely is just looking at how we did historically. The next level of analytics are more where you use a bit more into statistical analysis. They're also known as diagnostic analysis. In the terminology of analytics, when somebody says data analysis, that's what they mean. This is this type of data. Really, you're trying to aim to determine of the underlying reasons for what the data exposes. So now you're trying to understand why things are happening the way it happened. Still looking at some of the past information and trying to figure out if we can get to the underlying factors, root causes. Can we explain why the data is behaving a certain way? What kind of patterns, anomalies, relationships I might have between different factors? So when you're doing this kind of analysis, or you're starting to use some of the statistical tools to do the analysis, you're in this stage. Then you move on to a stage called predictive analytics. Really, what you're now trying to understand is what may happen in future. So we've gone from the past, looking at the past, understanding the past data, and then getting to what could happen in future. So you're now trying to do analysis to predict things, and hence the name predictive analytics. Here, the aim really is to build a model from your historical data. So instead of looking at the historical data, but you're trying to predict what will occur in the future, right? So we need to understand the way we're performing. Can I understand how I'm going to perform in future? If you have those kind of questions, then you build a model and you try to use that as the predictive analytics. The key thing to remember here is when you build a model, it takes a little bit of time to validate that model. So because you're building the model on historical data, so you have good understanding of historical data, you can get good statistical significance in it, which you've probably done in the second stage of the analytics. But for you to keep using that model to predict the future events, you have to make sure the future events or future data in future, when you get that, if you're able to validate your model is behaving the way things were predicted to be. So you have to kind of validate it before you start using that kind of model or use those analytics. If it's not behaving, then you have to go back to the drawing board and change it. Sometimes you just have a software which will predict things and people take that as the prediction. There is an extra step. That's all what I'm trying to highlight here to make sure that you validate the model. Then the final type of analytics is the optimization analysis. Really, now you're trying to get some kind of a recommended path or some kind of a prescription of what to do next. At this stage, really, the idea is you have multiple options, and you're trying to figure out, I want to achieve A, and to achieve A, which of the two options are the better options. So you do these kind of analysis, and once you've reached that stage of maturity, this adds tremendous value in your decision making. Now let's look at what each of the stage is trying to show us and what kind of softwares or approaches are out there. So first one, reporting. Really, you're at the metric stage. You're looking at lots and lots of metrics in your organization, different kind of dashboards, maybe different levels of organization have different dashboards, from all the way to the operators, miners, technicians, to your senior leaders. They would have different dashboards. They should have different metrics in those dashboards. But again, the aim here is some kind of a trend, some kind of a time chart, like history, compliance to target, percent on target or my performance, some kind of ratio charts. And then the Power BI and Tableau are two big ones right now, which gets used the most to do these kind of dashboards and reporting analysis. You could do this in Excel, or you can do this in the systems like SAP or Oracle, or like if you got like manufacturing, their own databases and their own dashboarding solutions. Like in mining, you may have Sandvik or Epiroc, who have their own systems, right? But all what they're trying to do is give you some kind of a historical understanding of that. And usually you can customize it based on what you need. Once you get to the data analysis stage, you're now starting to look for statistical information, as we talked about. So you're going to start seeing some visualization of your distributions, not just a snapshot, right? You're trying to see how I behave over time. What does that mean? Can I do something with it? Is it varied? Is it very tight, like in the way the performance is? Am I very consistent, not consistent? So you're starting to get that information. Histograms, frequencies, mean and ranges. We're all talking about either the spread of the data or the location, how I'm performing. Quartiles, and then some correlation is done in this side of things. So to prove that if I have identified a factor which is causing the impact on my performance, can I correlate it? So some of that analysis is also part of this. Again, Excel, SAS, or Minitab are the major ones that I've seen people use for these kind of Minitab. For these kind of statistical analysis. We've used a lot of Minitab in past. And then for people who are familiar with PyVision or PyWeb tools, they also have a lot of these analysis built in that you can use for these kind of things. Finally, when you move from the historical to future looking, in predictive, you're trying to build a statistical significance, right? So the idea here is now I need to understand, I'm about to predict the future events. The factors that are important to predict, do I have the statistical significance to use them in my model? So some of the regression, predictive regression is used for this, Monte Carlo to build certainties, data mining or historical design of experiments. There are very good tools to do this in the large set of data. Same tools as we use in statistical. RiskAmp is a good add-on, usually for Monte Carlo. And finally, once you get to the modeling stage or optimization stage, you're trying to answer the questions of what if analysis, right? What if I did this? What is going to be the impact? What if I changed the way I operate, the sequences, all different kind of what if analysis, whatever the factor you can think of, you can try here. So that's kind of, you're trying to get the answer. The examples which exist in market today that you are familiar with, I'm sure, are like digital twinning, the simulation models, machine learning, and now AI is getting in that world as well. In next few slides, you'll see it's not, there is a pitfall here that if you just go build a simulation model or a twinning without doing the different of the analytics of building the right level of intelligence, you're not going to get the right answers. So garbage in, garbage out kind of conversation. Some of the softwares which are used in this part of the analysis are listed there. Okay, let's move on to the part that I was talking about. What can and cannot you do with each one of them? So here are a few of the things I looked at measuring spot performance. So what I mean is you're trying to look at very short intervals of how my performance is. Comparative analysis, where you're trying to compare multiple things. Making sustainable planning. So you're trying to use your analytics to come up with a plan which is going to be sustainable. By sustainable, I mean you can consistently achieve the plan, and it has some kind of intelligence into it. Visualizing performance, so that's another reason you use the analysis. Aligning metrics, so you're trying to understand how one metric may connect to the other metric, like what is the relationship between different metrics or KPIs or KPPs. Forecasting performance, that could be another reason you do use the analysis. What if analysis we just talked about, and then there is a short interval decision making, where you're trying to look at your data or analyze the data to make very quick decisions. So let's look at each one of them. Reporting, very good for measuring spot performance. Then also good for visualizing performance or aligning metrics, but the rest of them is not very good. Why is not very good? Because you're looking at just the historical information. You're not just doing anything with it yet. It's more, it's trying to visualize the data and give you the trends or history. It's not going to be able to answer the question without bringing in some of the stats, some of the data stuff into it. So that's where you bring the data analysis. It will help you do some of the comparative analysis. It will help you do the make sustainable plan. So in this stage, you will be able to get to a point where you say, my plan calls for so many of things being made or so many things being produced, or produced at that cost. What are the chances of me achieving it? So that's where the stats get involved, and you can answer those questions from your historical data based on how you're behaving, right? So your performance is. Visualizing performance is still good. Aligning metrics is still good. And basically, this is it. If you're trying to go any further than that, you now need to start looking at building some models. So for predictive analytics, for sure, forecasting performance, every time you're trying to do something like that, you're playing in the predictive analytics box. So you have to make sure you follow the right path, and you've done the right statistical analysis up front to be able to build a model which predicts things. What would happen if you don't do that? Really, what's going to happen is your prediction is going to be usually way off, or it's going to be very wide. Your prediction bands between min and max, or between what you're going to produce, low versus high, will be very wide, and then prediction model doesn't really solve or serves the purpose that you're trying to do. So that's why you have to do some work there. And then short-term decision making, if you're in that box and you're trying to make some decisions, you need to be able to look at the historical and predict what's happening in the short interval. So you need a bit more ability to correlate, ability to establish statistical significance, and then predict how things are going to be. Finally, when you get to the stage of optimization, really this is going to be able to answer all of different things. It can do your spot performance in the twinning cases. It can do you comparing alternatives with simulation modeling. It can make sustainable plans. It can test the sustainable plans. It can do forecasting of the performance. What if analysis is the main thing you will get into optimization. So let me just give you an example. You have multiple ways to spend some capital, or you have multiple capital projects which are trying to improve the same thing. Usually, you will be able to run a simulation model or a twin to figure out which one gives you better results over time. So it helps you do that. Or you're not sure what an improvement is what part of the improvement you're going to get at the end of the values chain. Then a simulation model will help you do that. We'll be able to see where your value is being constrained or where your values is being consumed, right? So usually simulation models and optimization models are good for that. And again, short-term decision making, you can run it as a digital twin and test your decision before you implement it. So examples of these are like I don't know if people follow most of the team sports teams are now in this stage that are doing this, but the one that I know for sure is the Formula One. They've got so many different simulation models running as the race is running, and they're plugging in all the data which is coming from the cars, from their systems, and they're making live decisions in the simulation model to see what the impact will be, and then they're passing that on to their drivers and their teams. So that's the kind of short-term interval decision making we're talking about. Okay, so I did talk about in the beginning of journey to excellence. So I wanna spend some time here before we end the webinar. Really, what in my experience when I've been involved in implementing this, a lot of people play in the box of reporting, dashboarding, and data analysis. We don't really get to, we want to get to the predictive analysis optimization, but we never get there. And I think in my experience, the reason for that is we don't understand what each box pros and cons are, what it can and cannot do, or what's involved in it. As this graphic tries to show, it gets more complex as you move forward from reporting to optimization. I think everybody will understand that. But the value generated by each level or each step of maturity in analytics also increases tremendously. So if we were trying to the key here is if we're trying to answer the question of why it happened, we should know that we need to take the next step and build some of the intelligence in-house or in our whatever dashboarding tool we have. So if we're using Power BI, for example, we should start looking at the data statistically. We should start looking at the data maybe which shows us easily when a root cause has occurred or a factor which has become significant. We should be able to see that, not just see if I made the plan or if how my performance was, like what percent compliance I achieved. And if you're trying to predict, like the plan that I just made, forecast or predict, is that plan going to be achievable, then you're going to the next level. You need to have that intelligence in there. So if people start understanding what is required at each level, then it's easier to get to that level. Otherwise, it becomes one of those things where people think we're predicting, but you really are in the reporting stage. You're still trying to use your historical performance to predict that over the last 30 weeks, I was between here and here, so I can achieve this, right? That is really taking two spots or two or whatever numbers of weeks we just use 30, let's say 30 data points off a spot per week, which does not have the same statistical significance to predict. So you're going to, again, be sometime on within the prediction and sometimes not in the prediction. So it's not the right methodology to answer the question, what can happen, if you're trying to answer that question. So if you understand that, then you can implement it. Okay, just my last slide here. So effective decision making, really what you have to understand is what kind of problem you have or what tools you need. And it's not important that I have to use Minitab to start showing my data, right? Minitab is there to build a statistical significance, or simulation, whatever software you're going to use is there to build that signification. You can bring it back into your existing reporting dashboarding process. So Power BI can still show you a optimization analysis or predictive analysis as long as you build the intelligence in it, as long as you've done that work up front. And of course, if we're involved, that's what we're trying to find out first, right? We're trying to figure out what kind of problem we are, what maturity level we're in, what our KPIs are. Our KPIs, the metrics are at the reporting level, or they are trying to predict. If they're trying to predict, then we need to build that intelligence in. Okay, I think that's it for my webinar today. I'm 2 minutes ahead of schedule, so I will open the floor to questions if anybody has any questions or comments. And I also have some polls if you guys can look in that on the bottom in the circle, triangle, square thing. And answer those questions for me, please. Okay, I'll open it for questions. Anybody has any questions? Okay, quite a bunch. If you have no questions, thank you for attending, and we'll see you next week.
Thanks, Austin.
Yeah, have a good one, guys.
Thank you, Austin. Great work. Thank you.
Tim.
Thanks, guys.
All right.
Thank you.